Hello everyone, myself B. Narayan Prasad. I am going to explain about our project. We have done a project based on security. Our project title is Image Encryption and Decryption using Dynamic AES algorithm. Our guide is V. Sahiti Yellanke ma'am. We have done this project with a group. Our team members include Krishna Teja, Deepak, Sharath Chandra. Let's discuss about abstract of our project. Image encryption and decryption techniques plays a crucial role in safeguarding sensitive images from unauthorized access. The advanced encryption standard is a widely adopted algorithm for encrypting and decrypting images. This presentation focuses on image encryption techniques that integrate shifted image blocks of the dynamic AES algorithm. Additionally, the RSA algorithm is employed to secure the encryption key used by the AES. AES is a symmetric encryption algorithm that operates on fixed size blocks of data. It supports key size of 128, 192 and 256 bits, making it highly secure. AES divides the image into blocks, with each block typically consisting of 1028 pixels. The algorithm applies a series of mathematical operations to encrypt and decrypt these blocks. Shift-left image blocks with shift technique. In this technique, rows and column blocks of the original image are shifted to create a modified shifted image. The purpose of the shifting is to introduce confusion and make it harder to discern patterns in the encrypted image. The shifted image serves as the input for the subsequent encryption process. The dynamic AES algorithm encrypts the pixels of the shifted image using a dynamically generated encryption key. This key is generated within the algorithm to enhance security. The dynamic AES algorithm applies the AES cipher method to encrypt the image data block by block. Each block is processed independently, ensure that modifications in one block does not affect others. And let's discuss about the algorithm of our project. The algorithm used in the project is Dynamic AES encryption standard. It can be used for both encryption as well as a decryption. It is a symmetrical block cipher algorithm that takes images input and divide into 128 bits and converts them into ciphertext. For the encryption, we use the QFile dialog method, which we can read the input image from the file, and we have to collect the date of birth information from the receiver and they use the date of birth as encryption key. And by using RSA algorithm, we have to generate public key and private key using generate RSA key pair method. And the RSA public key method is used to encrypt the encryption key. By using AES cipher method, we can convert image into blocks of 128 bits. By on clicking encryption button, the encryptor class take blocks and encryption key to convert the image into ciphertext and store the ciphertext in a cipher.txt file. And in the decryption process, we use QDialog method to read the ciphertext file, and by using RSA private key, we will decrypt the encryption key. And we have to enter the encryption key to decrypt the ciphertext. The decryption will be opposite to the encryption process. By on-clicking decrypt button, the decryptor class takes ciphertext and encryption to convert the ciphertext into original image. And this is our project implementation. And first we have to take the main.py file. In this we have used pyqtify widget in order to implement the web development of our project. And first we have to load the UI and we have to have the encrypt page where we handle the buttons, and we have to choose the file which we have to encrypt, and on clicking the encrypt we will convert the input image into ciphertext. And next we have the decrypt page. In this we have to take the ciphertext file, and by on clicking the decrypt button, the ciphertext is converted into original image. And this is the overall code. And for both encryption and decryption, we have separate py files. First we will discuss about encryptor.py file. In this py file we have to take the valid keys where we can accept only date of birth of the receivers, and if it is not present in the valid keys, then we have to raise an error, and we have to generate our private key and public key by using RSA, and we have to encrypt the image using AES cipher, and we also have to encrypt the key. And in the decryptor class we have to decrypt the key by using the private key, and we have to decrypt the image using the AES cipher. And this is the output of our project. In this we have to select anyone, encrypt or decrypt. First we select encrypt button. After clicking encrypt button, we will have this widget, and in this we have to enter a key which is date of birth of the receiver, and we have to choose the file, and we have to click on the encrypt button. Then it is converted into ciphertext, and we have to go back and we have to select the decrypt button, and then we will get this widget. In this we have to choose the ciphertext file and we have to enter the same key and we will decrypt. By this, the ciphertext is converted into original image. And the conclusion of project is image encryption using AES offers reliable and secure method to protect sensitive image data. Decryption of the encrypted images requires the correction encryption key, allowing authorized individual to do decryption process and retrieve the original image data. As long as the encryption key secures the image, remains protected from unauthorized access and brute force attacks. Overall, image encryption using AES algorithm provides a robust and efficient solution for safeguarding sensitive image data. Thank you.